Hello everyone. This is a great example about an application of electric field flux going through some kind of like a surface or a closed surface or any type of surface. So we have here a cube, and as you can see in this cube there is an electric field going from left to right, and the electric field value is 300 Newton per Coulomb, and we want to find the flux going through the right side of the cube. So this is what we are concerned of. So this is the right side of the cube. Okay, if we know that the cube has a side of 2 meters, so 2 meters by 2 meters by 2 meters, now we need to find the flux going through this side. Okay, now let's analyze a little bit. We know that for this side we are going to, so this is a cube like that sitting on the ground. This side you can't actually see, it's behind you, but the normal to the surface of this side, to the right hand side of this cube, is going this way, and the electric field, as you can see, it goes through the box itself and it impinges from the other side going out. So the electric field and the normal as a direction are both at the same direction, so you can tell that theta here is equal to 0. So if we want to find the flux, phi is equal to EA cosine theta. Now E is 300 Newton per Coulomb, and A is the surface area, this surface area here, and this surface area is 2 by 2, so 2 by 2 times cosine 0. Cosine 0 is 1, and if you do this calculation, you would be able to find that 3 times 4 is 12, 2 zeros, so that's 1200. Now what is the unit of the flux? If this is Newton per Coulomb, that's for the electric field, times meters square. Okay, so it's Newton per Coulomb times meters square. There's no simplified unit for this one, but let's just keep it this way: Newton per Coulomb times meter square. Okay, now let's see if we can find the electric field flux on this side, this one here, which is the left side. Now the choice of the normal, usually the choice of the normal is always outside the surface. So if this is the surface that we are looking at, okay, then the normal will be here for this side. Okay, so if we assume that was surface number 1, so we found here, I'm going to call it phi 1. Now let's find phi 2, applying exactly the same equation, which is EA cosine theta. Here we know that E is the same, 300 Newton per Coulomb, and A is the same, which is 2 by 2, which is 4. And now theta, as you can see, the electric field, as you can see, the electric field is going this way, and in the normal to the surface going the opposite way. So the angle between the two is 180 degrees. So this is 180 degrees, so I'm going to say cosine 180 degrees. Okay, cosine 180 degrees is actually 180, that's minus 1, and the answer is minus 1200 Newton per meter times Newton per Coulomb times meters square. All right, now what if I asked you to find the net flux that is going through the whole cube, the net flux? Okay, we have basically how many surfaces for a cube? We have 6 surfaces. So according to the flux equation, the flux in general for any closed surface is equal to E summation over I AI times cosine theta I. Now let's look at, we already calculated for the surface surface number 1, and I'm going to call this surface number 2. So this is number 1, this is number 2. Let's calculate the flux for the other surfaces, which is this surface. I'm going to call this surface number 3, and this one at the bottom, number 4. And the one in the front, the one that you see here, this big one here, I'm going to, this one here, this one, I'm going to call this number 5, and the one in the back behind it, where we can't see it, that's number 6. If you actually take one by one, you will find that each flux that passes through each of these surfaces, the side surfaces that are not being penetrated by the electric field, you're gonna find that the flux is equal to 0. Let's take this one as an example. I'm gonna make it just green so that we can look at it more in detail, and then we will generalize it. Look, the normal to this surface is going up here. So that's the normal. And look, the electric field is this direction. What is the angle? It is 90 degrees. Cosine 90 is what? You should know that. Cosine 90 is equal to 0. So basically, phi coming from surface number 3 is 0. The same argument here. Look, n is down, E is here, 90 degrees, another one. Now the surface that is facing you, because it's facing you, the electric field is going this way, right? And the normal is going this way. So look at the angle; it's also 90 degrees, and the back one is 90 degrees. So all of these contributions from this guy, this surface, and the back surface are all not add up. Their contribution is 0 for each one. Now look, this surface is minus 1200 Newton per Coulomb meters square, and this one is 1200 Newton per Coulomb meter square. So if you add these together to find the net, right? So the net ends up to be totally 0. Okay, and that is actually true for any closed surface. Any closed surface, the net flux that goes through it, it's 0. So any closed surface like this, it's a closed surface. So think about it as 3-dimension. All right, and there is electric field that goes all the way through it. The net flux is going always to be 0. So I'm gonna bring you to this example here. Look, for example, if this electric field, which is 300 Newton per Coulomb, is going through all of this surface here, this part here has less flux than this big part, because this is a huge surface. Okay, now this does not contribute anything. The one facing us does not contribute anything. The one facing backward is not contributing anything, but this one here has some flux going through it. Yes, it's going with an angle, but if you calculate this flux going through here, okay, add it to the flux. So I'm gonna calculate this flux here, add it to this flux here, it will add up to be the same as this one, but in the opposite direction. So the flux here, the net flux, I'm going to say net flux here would also be equal to 0. Okay, that's it for the example. Thank you very much.